Okay, so now let's talk about hazard analysis and control. So, objective, we're going to be looking at acquiring basic knowledge for identifying hazards and figuring out what to do about them, basically. This is focus with unsafe practices in the workplace. So, hazards are basically anything that has the potential to cause an issue: injury, occupational illness, damaged property, damaged equipment, so on and so forth. So you know, it doesn't necessarily need to occur. It's that it could occur. If there's a slippery floor, it's still a hazard if the floor is slippery, even if no one ends up slipping. So, in the workplace, got two general categories: task hazards and workplace hazards. So, task hazards are basically something inherent to do with uh, whatever you're performing, whatever task you're doing. So, typically, we're speaking, we're grouping them into chemical, physical, or biological hazards. So, an example: exposure to solvents that you're using. So, working from a height, working with electricity, working with chemicals. And then workplace hazards, we got conditions in the environment that you're working in that affect kind of the workplace as a whole. So, it might not necessarily have something to do with what you're doing. It's a hazard associated with where you are. So if it's cold, if it's hot, if there's slippery surfaces, if there's a risk of fire, so on and so forth. So, a couple examples. The smoke in the area might hit people walking around. Um, here we see an example. So, this guy here, he's welding, right? So he is, he's got his visor on, he's got his gloves, so on and so forth. He's protecting himself from his task hazards. But you, being in the area, walking by, if you happen to glance in that direction, you're not the one doing the welding, but you could still have damage to your eyes due to the light being emitted from there. So that would be a workplace hazard. And then here's an example of a workplace hazard if you happen to be working on an oil rig that blows up, or say working on an oil tanker that catches on fire, like we saw with the protector. So breaking them up, so physical hazards, some sort of energy that is strong enough to cause injury or disease. So we're talking high temperatures, moving machinery, electricity, light, noise, vibration, radiation, etc. So it's causing direct damage to your body. So here would be an example. Cold. You also got the wind blowing. You also the possibility, the risk. I mean, if the thing crashes and you're going to get hit by the rotor, so on and so forth. Another type of hazards, so chemical hazards. You're exposed to a chemical in the workplace that has an adverse effect to you. So again, could be a solid, liquid, gas, so on and so forth. So welding fumes, cleaning products, battery acid, solvents, perfumes, etc. So yeah, could be poisonous, could have other adverse effects. Could be immediately poisonous, could cause cancer down the road, so on and so forth. Biological hazards, so things that are causing uh, causing a problem to you via something that's alive, basically. Bacteria, viruses, insects, plants, birds, animals, other humans. So you could get COVID-19. That would be a biological hazard, and I'm pretty sure we're all quite used to dealing with that particular subset of biological hazards as at this point in time. Psychosocial hazards. So typically speaking, we're talking the effect that the workplace might have on a person's psyche. So, workplace violence would affect things. Burnout, stress, harassment, post-traumatic stress disorder, absenteeism here. That's not really, I mean, that's kind of a symptom of yeah, oftentimes the ones listed here are kind of symptoms of the psychosocial hazards due to stress in the workplace. And then we got ergonomic hazards. So basically, those that have to do with the design of the workplace, the workstation, what you're using, and oftentimes they most often come up with awkward and repetitive movements. So that, you know, essentially you want to be ensuring that if someone's doing something frequently, that they're not being forced to move their body in various ways that could cause harm over time. So you might get carpal tunnel syndrome if you have a poor typing setup. You might have back pain if you have a really shitty chair, so on and so forth. Or again, not just, we're not doesn't just happen in the office. If a worker on an assembly line needs to keep bending up and down to pick up something from one conveyor belt, move it over to the other, then that would be an ergonomic hazard. So in the forces, we have methods of identifying and reporting these. So the D&D 663 is the General Safety Hazardous Occurrence Investigation Report. So these are to be used when hazards are identified. They're also to be used when accidents occur, because again, if an accident occurred, there must have been a hazard associated with it. You can't have an accident without a hazard. You may have hazards without accidents, but you can't have the one without the other. Audits, inspections, and surveys occur. And then the unit general safety officer will be kind of in charge of this, and various data gets recorded on safety failures that happen, and if we do get incidents happening enough, then hopefully some sort of change will occur. So, for example, on the Halifax class frigates, the ladder outside of the ops room, that there's a relatively tall, steep ladder right outside the ops room, and that used to be a down ladder, and people kept falling down that ladder. So what they did was they switched it they switched the direction of flow. That one is now an up ladder, and another ladder nearby that isn't quite as steep got changed to the down ladder, and as a result, people are less likely to fall. I think, not gonna lie, I was the unit general safety officer for the Vancouver when that occurred to the commanding officer. And I think that was probably the instance that prompted that change. So I would like to think that maybe it would have happened if it hadn't occurred to, again, the the captain, but you never know. But anyways, so if we have hazards, and again, there's basically nothing that we do that is completely safe, but there are things that we do that are less safe than we'd like them to be. So we need to work at identifying and controlling those hazards. So we want to prevent workers from being exposed to the occupational hazards. So there's two basically main methods of doing this. We've got engineering controls and we've got administrative controls. So the engineering controls are the most effective, and those are used to basically eliminate the hazard completely substitute it with something less hazardous, isolate the hazard, so put it in a different room than your workers. You can have ventilation or modify the equipment in order to reduce the likelihood of an incident occurring. So you want to be designing the work environment and designing the job so that exposure to hazards is eliminated or reduced in severity. So I'll give you a bit to go watch this video. All right. So yeah, there's a hierarchy of controls. We want to be using elimination and substitution to start off with. There's other engineering controls, and then administrative controls are the least effective. So again, delving into it a bit more. So eliminating, getting rid of the tasks, getting rid of the dangerous material, so on and so forth. Especially, you can if there's a hazard caused by something that's broken, we replace that. That's a simple way to go about things, right? Substitution, we're swapping things out for something that's less hazardous. So maybe there's a material that we need to use in some sort of chemical process, but there's a couple of things we could use to kind of attain the same result. Maybe we want to go for the one that's less poisonous. That would be a great way to go about things. Equipment modification, so adding guards to stuff so that people can't stick their hands into the rotating parts. That they physically can't touch any electrically charged components. That it'll prevent them from putting their hands on any hot parts of the machinery, so on and so forth. So here's an example. We've got this belt here, this belt system. So here we're trying, obviously we're using this because we want to take our energy in, our mechanical energy at one particular speed, and either step it up to a higher speed or step it down to a lower speed. And in order to do so, we're using this belt and pulley system. So we throw a guard on there in order to make sure that no one can accidentally stick their hand in that belt and then get it torn up or chopped off or what have you. So sometimes we might use isolation. So if we can't eliminate the hazard, what we can do is we can put it somewhere else. So we can have a control room that we stick our workers in, and they can be the ones who are remotely managing the processing of a toxic chemical or what have you. So an example of where you might be able to isolate your processes in. So sometimes you might just want to enclose the machinery. So again, a glove box would be a suitable example where you're able to, you got a box, you've got these gloves attached to the box, and you can still manipulate what's going on inside through the gloves. So you're not completely isolated. You're not completely isolated from the process. The person's still right there. So obviously, if the glove box fails, then the person's going to be potentially exposed to the chemical instead. But it's a layer of protection that can be used. So here's another example of an enclosure, and here type of glove box that I was talking about. Ventilation can be very helpful. So regulating temperature and humidity levels is fairly important. And we want to, we don't want people to be uncomfortable. We don't want them freezing. We don't want them getting heat stress, so on and so forth. And then, of course, keeping the contaminants in the air from getting to where the workers breathe, or if you can't eliminate that completely, keeping levels of the contaminants below a certain safe threshold.
So next up, we got administrative controls. So these are used to augment your engineering controls. So basically, procedures, policies that are put into place that, when followed, will allow your workers to do the job safely. So again, obviously, you need to establish your procedures. You need to train people on your procedures. Put up warning signs, so on and so forth. Establish codes of practice to follow. And then, if followed, things should be safer. That's when the problem there is the if, because oftentimes workers will ignore administrative controls. Maybe they just want to get out of their bed early. Maybe they're lazy. Maybe they're complacent. It happens as as a as a upcoming junior leader in the Canadian Armed Forces. It's still up to you to ensure that the policies and procedures that are put into place in order to protect people are followed. So we want to be, well, one administrative control is limiting exposure, so we can maximize the distance between the hazard of concern and people, or limit the duration. So, for example, when radiation hazard. So on ships, each emitter will have basically a safe zone around it. So as long as you're not within a certain distance from the emitter, you're deemed to be operating safely. And that's established by basically kind of taking measurements of the amount of radiation that will be passing through a person if they were standing in a particular spot when the emitter's on. Another example would be, say, for the duration. One thing that happens often here at RMC is that it gets hot during the summer. The air conditioning systems, at least in the past, have been inadequate. I know they've done some work in the past couple of years and it might have been improved, but Sawyer gets disgustingly warm in the summer, and so you'll often see emails going out saying, "Hey, it's this hot in this space." Happens in Massey too quite often. So basically, they'll mandate that all right, workers are only allowed to be employees are only allowed to be working in this area for X number of hours per day, and then past that, then alternate arrangements need to be made. So they could be working from home, they could be working, from some other alternate location on campus, so on and so forth. I really hope they fix the AC on that, because anytime I need to come in summer, I usually just need to wear my PT gear instead of my uniform because it's way too disgustingly hot. But anyways, selection of personnel comes into play here, so you need to ensure that the people that you're choosing to do jobs are adequately trained. So they got the skill set and they've got the experience in order to do that job properly and safely. So they're not only just ensuring that they're not going to, get themselves injured, but they're also not going to injure others. Well-tested procedures, clear procedures, easily followed procedures. Checklists are very helpful for this, but you need to ensure that not just establish these procedures, but make sure that they're followed. You can't just come up with a bunch of rules about how you're supposed to do the job and then completely ignore it when people deviate from those procedures. So education and training comes into play. You need to educate people as to why the practices are important, train them how to do stuff properly. Ensure that basically they get a good idea of what'll happen what could happen if they don't follow the procedures, and how to do so, how to perform this stuff properly. Warnings are important too. So again, if you're going to be using them, they need to be designed to easily attract attention, easily recognized and easily understood. So some warning signs, use standard warning signs when possible. You don't want people to be encountering a warning sign that they need to figure out what it means. And of course, some other devices may be useful here too. So, like a klaxon that's issuing a very loud audible alarm with a bright flashing light is going to attract attention. And as long as the people working in the space have been told what that means, then they will react accordingly. So that plays into your training as well. So, a classic example here would be the fire alarm is a perfect example of a warning device that is easily recognized, and people can act based upon that. So promotion, motivation, it's up to the general safety organization to essentially provide training and distribute promotional material, and also recognition of achievements can be important too. So if you had a workplace that's gone quite a long time without having an incident, then that's a great thing. So you might want to I don't know, have a pizza party or what have you. Free food always motivates people, I find. And then we got our PPE, so personal protective equipment. It is very important to use proper PPE, but you don't want to be relying only upon the PPE. The problem is with PPE is that if it fails, then again, the hazard's right there and the person is immediately exposed to it. So, if you've got one of those big biohazard suits on and it tears, well, guess what? The person now is wearing a giant container that has that has the hazard leaking inside it. So, not ideal. You want to be trying to eliminate the hazard at its source using engineering controls first. Eliminate it, substitute it, what have you. And then PPE is our last ditch effort. Obviously, sometimes we can't completely eliminate the hazard, so we need to rely upon the PPE. So, for example, if you need to weld stuff together, then assuming that using a robot to weld it isn't feasible, then you need a welder. The problem is that welder needs to be right there. So he or she's going to need proper PPE to shield them from the fumes generated, to shield them from any heat generated, any sparks or what have you, or any bits of slag, and as well, obviously, the protection for their vision. That PPE is very important. You can't do the job safely without it. Disadvantage, of course, it's uncomfortable. People don't like it. Bad for your work performance, and you can have new health and safety hazards. So ear protection might prevent you from hearing warning signals or just hearing someone talking to you. If you're wearing a biohazard suit, or from when you did your CBRN training during basic, if you're wearing the full level of protection of the highest order of the suit all day every day, then that would be absolutely terrible. Morale would be terrible, but you'd have people overheating. You'd have people losing their situational awareness. If you're all bundled up, then you can't hear and you can't see as well. So you're going to be less able to notice other hazards in the area, whether it be maybe you just can't see the slippery patch on the floor, or maybe you can't see the enemy firing at you from across the way. Obviously, military sometimes has to deal with different hazards than your average workplace. But here's a few references. On the DWAN, so Guide to Hazard Analysis, and the DG, uh, the Director General for Safety website. But yeah, be aware, be safety conscious. Don't do what Donnie don't does here. Don't pay lip service to safety. Don't throw up the think safety first banner in a completely unsafe manner. Don't let other people do unsafe things around you. But yeah, and we'll move on to the risk analysis lecture in a bit.